Hey, today we're going to talk about 1.7 hydrologic cycle. So check out the enduring understanding, look at the learning objective, and pause the video, review the essential knowledge, and set up your Cornell notes. So the hydrologic cycle is our last biogeochemical cycle that we're going to discuss, and it's a fancy way of saying water cycle. You should have learned this in middle school, elementary school, some other science class. I'm just going to provide a little bit more details to this because there are specific processes that you want to understand. Now, anytime that someone says the hydrology of something, if a question ever asks about the hydrology, all that means is you have to pick something from the hydrologic cycle. So I'm going to go through the different steps. The most important thing is the hydrologic cycle is driven by the sunlight. So the more sun you have, the more intense solar energy you have, the faster the hydrologic cycle will occur. That's why you have a lot of rain in the tropics, because you have such extreme solar energy and powerful solar energy driving this hydrologic cycle. So the different steps. The first thing that would happen is, now this is not the first thing, but it's the first thing that I'm going to talk about. You could really start it anywhere, but evaporation occurs first. Evaporation is when the water is going from liquid to a gas. Another sublimation is going from a solid to a gas. That also occurs. I don't think you're ever going to be asked that. But if you are, you don't have to know it, but you can look it up if you want to. Transpiration is the process of plants releasing water vapor from the stomata in their leaves. Sometimes you may see this called evapotranspiration, where it's water going from the surface up into the atmosphere in the form of water vapor. Now, this water vapor is a very powerful greenhouse gas. It is powerful in the sense that it has a lot of warming potential, meaning it will warm the atmosphere. You've probably noticed that, like on hot summer days when you have a high humidity, you have a heat index. So it might be like 90 degrees, but it feels like 105. That's because there's so much humidity. It is having a heating effect. It's absorbing the sun's energy and warming the air around it. Okay, so sometimes you may see evapotranspiration written together, and you may see it separated. But both of these involve water vapor going from the surface, whether it's in the ocean or in the plant's tissues, into the atmosphere in the gaseous form. When there becomes too much water vapor in the atmosphere, the water vapor condenses onto little tiny dust particles in the atmosphere, and they form clouds. And if you look outside, you'll see that the clouds are a little bit gray. That's because there's dust particles that they're forming, the water is condensing to. When they become too heavy, it falls back down as precipitation, and it can be in the form of rain, snow, sleet, hail. All of these are examples of precipitation. It's not just rain, understand that. Okay, so again, going from water vapor into a liquid water is precipitation falling back to the earth. Now, runoff is when it moves along the surface of the earth. So precipitation is falling back to the earth. Now, when it goes and flows into a river somewhere else, that is runoff. Infiltration is when it is absorbed into the soil. So infiltration, if you've ever seen water draining into the soil, like if you water your plants and you can see the water like being absorbed, that is infiltration. And that's important because a lot of these nutrients and these chemicals, these molecules that are on the surface, they are soluble in the water, and those molecules can be drawn into the soil where they're available to plants and other microorganisms. And once you have infiltration into the soil, that's what these little tiny blue dots are representing, then you can recharge an aquifer. And an aquifer is basically a fancy way of saying groundwater. And this aquifer is water underground. If you've ever been to if you've ever been to the ocean and you sat on the beach and you dig down, and you'll see like water starting to flow in. Well, that's basically what an aquifer is. You have it, you dig down into the soil, and you have a layer underneath the soil where water molecules are held between like pockets in the soil, little air pockets. Okay, so you recharge the aquifer, but also you can cause this water to flow, because remember, water is going to go to lower elevation. So it's going to go to the lowest point where it will settle. So this movement eventually will make its way, the water in the aquifers can eventually make its way to a lake, to a river, eventually to the ocean, where it will evaporate and begin the cycle all over again. Now, this is our hydrosphere contains all the water on the planet, but only 2.5% of that is fresh water. So of the 100%, if you think like 100 milliliters represents all the water on Earth, only 2.5 milliliters, or like, you know, just a matter of drops, are going to be fresh water. And that means that it just is not salt water. Now, of that 2.5%, 69%, or roughly 70%, are locked away in the ice caps, polar ice caps, and in glaciers. So it is frozen where it is not accessible for human use. 30% of our fresh water is underground, in groundwater. So it's stored in these aquifers beneath the Earth's surface. And only 1% of all of the water on Earth is surface water. That means all of the lakes, all of the rivers, all of the ponds, the freshwater wetlands, all of those areas, only 1%. So if you looked at a map and you see all these lakes, only 1% of all of our fresh water is surface water. The rest of it is underground. So we have a lot more water underground and a lot more of it tied up in the polar ice caps. All right, that's one of the reasons why we want to prevent, excessive climate change and excessive global warming, because we don't want to melt the polar ice caps. We don't want to melt these glaciers, because it's going to add a lot more water to the oceans, and it's going to impact a lot of biodiversity, and basically it's the topic of one of the major topics we're going to be discussing all year. Okay, so for the FRQ practice, I would like you to identify and describe a process in which water moves between reservoirs in the hydrologic cycle. So I thank you very much for your attention. I hope that this video was informative. I will see you very shortly.